This is a quick video to show you how to perform structural analysis and design of a 3D reinforced concrete structure. So as before, we have to use some settings to start our problem. So we are going to use the units as US customary, steel sections, but these are not really relevant for the problem. But as far as our reinforced concrete design is concerned, we have to make sure that this is the standard that we are looking for. So it's ACI 31814. Then for the current problem, what we're going to use is I have given the column layout of reinforced concrete structure. So what we have here is several columns which are laid out in this fashion. We have several columns here which are named as the grid layout is named as in terms of A, B, C, D, E, and 1, 2, 3, 4. So to identify a column, we can just call, for example, C3 corresponds to this particular column. So this is the layout that we need to work with. And regarding the story height information, we have 8 feet here, 12 feet here, and 12 feet above. So let's see what the analysis, what the modeling looks like. So we are going to use a custom grid spacing. Now the uniform grid spacing has uniform spacing between in the x direction and the y direction, but this is not possible, or this is not possible for the current problem. So let's use a custom grid spacing and we can edit the grid data. So from the plan we see that we have A, B, C, D, E, and we have 1, 2, 3, 4. So here we can just hit on add just to add one more, and here we can either use the x ordinate or you can simply use the grid spacing, which is much easier. So our grid spacing is 14 5 5, but between these grid between A and B it is 7, so 7 7 5 and 15. So all you have to do is 7 7 5 and 15. So this is ready right over here. And then regarding the y data, 1 2 3 4, we have 13 6 12. So we have to write 13 6 and 12, and our layout is ready. Now we can also change the bubble size. 60 might be a little large, we can use 30, and let's call this grid system as G1 and let's hit OK. And now the grid spacing or the grid layout has been prepared, or the beam layout has been prepared. And let's see what the story height information is. So based on the problem, we have 8 feet, 12 feet, and 12 feet. So let's use number of let's use we have 1 2 3 stories, so that is 3, and we have the typical story height as 12 and the bottom story height as 8. Click on OK. Now we can define some of the materials. So we go to define material properties. Let's create a new material. Let's create the concrete first. Click on OK. Let's name it as CONC, let's say 5000 PSI, and then in the modify material data, let's update it to 5000. Click on OK. and then okay, let's create this material steel. So let's click on steel. Let's name it as steel 50 KSI. By default it is 50, so click OK, and so the two materials have been created. Now the next thing that we need to prepare are uh, the frame sections, which consists of the beam as well as the column. So to define the frame sections, we have to first going to define, and then we have section properties. We have the frame sections. So let's create a new property. Now these are some default sections, but we are not really interested in those. So let's create a new property. So let's create the column first. So COL, let's create a 12 by 12 inch column, and let's put the numbers as 12, 12. Now there are some modifiers here regarding the rebar. So this is column by default, and you can leave them as it is. Click OK. And then regarding the property modifiers, when we look at it, we have this moment of inertia about 2 axis, moment of inertia about 3 axis. According to the standard, we do have the provision to reduce the moment of inertia. So as you can see, moment of inertia and cross-sectional area of members shall be calculated in accordance with tables A and B unless a more rigorous analysis is used. If sustained lateral loads are present, I for columns shall be divided by 1 plus beta ds, where beta ds is the ratio of factored sustained shear within a story to the maximum factored shear in that story associated with the same load combination. So we can really reduce the moment of inertia of the columns to 0.7 times. So that can be done over here. So it can be written as 0.7 and 0.7. Okay. So that is regarding the column. Now let's create one more property for the beam. So let's create a beam. Let's give dimensions of 12 by 24. So the depth is 24 and it's 12, and go to the modifier. Then we can click beam and then show modifier for 7.7. Click on OK. So once that is done, we can also specify the concrete here. Okay, this one also I have not done it, so just go and specify the concrete right over here. So we have a concrete column and a concrete beam. Now we can also define our slab section. So create a new property. Let's call it slab 6, denoting 6 inches. Concrete strength is 1000 psi and it's 6-inch thickness. Click on OK. Now once this has been done, we can start assigning some of the members. Now to apply or to assign the column, there is a quick way to do it together. So to do that, we have to look into a feature here which says one story. So there are 3 options here which says one story, all stories, and similar stories. Now you know that columns are there in all stories. So if we use all stories and we assign the quick assign property or the quick draw column property, and then we take the column here 12 inches and we just have to drag here and we have column throughout. Now suppose that I just chose one story, and you can see that currently I am at level Z is equal to 32 feet. I can press this button to go to other levels as well. So suppose I am here and I just drag, I can get a column here alone. But in this case, I need column from the top to the bottom. So I just have to select all stories, just drag, but you have to drag them based on the problem. We have one here, 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 and so on. So we have to put the columns accordingly. So we have columns here, we have columns here, we have here, 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 we have here, and we have here and here. So this is the column layout. We have assigned all the columns. And now we can assign the beams. Now to assign the beams, we use this tool, which is quick draw beams or columns. We can use this one also, and then we take the section called beam 12 by 24. Now here we need to use another property. If we use all stories and we click, there will be beams at the bottom also. We don't want a beam here. Now to assign beams, we may click all stories and start assigning the beams. The beam section is beam 1224, and you may start assigning the beams. Here and if you want this to be a single member, the issue is if we click them as separate, there'll be a node in between. So to avoid that, we may use this tool wherein we can just click and drag and drop at the beam centroid, and then we can just drop at the beam centroid, and again here to avoid the same issue, and once again here, and you can see that the beam has been or the structure has been created. Now to see the extruded view or the actual extruded view, we just need to click this. When we click this, this one, we will get the extruded view. You can see the sections, and we can just make sure that our assignments are all correct and that there are no surplus beams. Suppose that I did not connect it properly. If there is a beam here, it will be much clearer when it is in the extruded view. Once that is done, we can start assigning our slabs. To assign the slabs, we might have to use similar stories. Now the idea of similar stories can be changed and in the grid layout. For example, if I need to go back to the grid layout, if I need to make some modification to the grid, all I need to do is right click over here, modify grids, and then here modify or show the grid system, and we can in the not the grid system, the story data, I can assume this as the master story, and this will be similar to, when I say similar stories, this is what I mean. So if I want to use slabs for the roof and the floor below, and I want to skip that, I can just use none here. Okay, and OK, which means now the similar stories are just story 3 and story 2. So if I take story 3 and then I assign my slabs here. So I want to assign my slabs. I just click and drag here. I assign my first slab, and you can see that slabs were assigned only on these two stories. Now, since this is the ground floor, we need not provide a slab which is framed to the system, because this is like a ground supported slab, because there will be soil filling up to this height, and it's just a ground supported slab, so that is not directly, or it is not connected to the reinforced concrete frame. So we can assign the remaining slabs here. I can click, drag, second slab, click, drag, third slab, fourth slab, fifth slab, sixth slab, the last slab. So now we have assigned all the slabs. Just to see the extruded view, I can have a look at it now, see how it looks like. Now since that is done, now let's move into the load application. Now for that, again we need to define some load patterns, and we know that we have two load cases here. For the current problem, we will just look into the dead load and live load, and the next problems, the next sessions, we will see earthquake load and wind load coming into picture. So in dead load, just let's rename it as DL for our convenience and just modify the dead load, and let's modify the live load as simply LL and modify the load. I just modify the names without modifying properties. So click on OK. So now I need to start applying some of the loads. Now when it comes to the load application, one may think, what are the loads, or what are the numbers, or the unit loads for the distributed load that I need to apply for the structure, and what does the standard say? So for the current problem, we will be looking at ASCE 7, which is the standard that specifies the minimum design loads, minimum live load, dead load that need to be applied for structures. So let's take the manual. So when we take a look at the ASCE 7 minimum design loads for buildings and other structures, when we search for the design loads, for the dead loads and the live loads, we will be able to get the numbers that are required for entering into the analysis. So for example, when I search floor finishes, it takes me to a table where some of the values for floor finishes are available to us. Like for example, ceramic or quarry tile on half-inch mortar bed is 16 pound per square feet, and also several other types have also been listed. Like if you're using hardwood flooring, this is the number. If you're using marble and mortar on stone concrete fill, we do have another value. Slate, we do have another value, and a lot of information regarding the dead loads have been provided. Now this table is called the minimum design dead loads. So these are the values for a lot of cases, which makes the calculation, or makes it easy for us. So in the software, now let's assign a shell load. Now before assigning a shell load, let's use the select tool. We have select object type, we have floors. So when we select the object type of floor as floors, we are able to select, the software automatically selects the floors alone without considering the beams. So when we select this, you can see that all the floors have been selected, and on the right hand side we see that it has been selected on uh, both the levels. So we can enter the value to assign. Let's go into shell loads. We have a uniform shell load, and this is the dead load because its floor finish is always considered to be a dead floor, a dead load, and we enter the value 16 as we saw before, and we have the option to replace existing loads. There are no existing loads at the moment, so we can just, it doesn't matter whether we click add or replace, it's just going to apply the value. Click on OK. So now we have some floor finishes added to it. The load for the floor finishes added to it, and then we can now search for the loads for residential structures. For that, when we take a look at the initial pages, when we get into live loads, and when we go ahead, we'll see that the minimum uniformly distributed live loads and minimum concentrated live loads that need to be applied. So we have here a residential building with private rooms and corridors serving them, which is around 40. And if there are some public rooms like halls or something in your structure, so it has to be increased to 100. This is because we expect larger concentration of loads, a lot more people gathering in the public rooms. So we can go ahead with 40. So now in this case, I need to only apply this load to this flow. We don't need to apply unless this is considered to have dwelling there or residence there. But in our case, let's assume that there is no load here besides the minimum roof load that needs to be provided. So we need to apply this live load only to this particular floor. So just select one story, and then let's move it down to 20 feet. So what I mean is this floor, and then let's apply the shell load again. So assign shell loads, and you have a uniform shell load, and this is considered in the live load pattern, and we apply the value of 40. And this is in live load, so even replace or add doesn't matter because both are two different patterns. So click on OK. Now that load has been applied to this floor, but unfortunately we did not select them, so that load was not applied. So let's select them again. Either we can select them as I mentioned earlier by just clicking on them, and then assign shell loads, uniform shell load 40, apply. Okay. Now to just make sure that we have assigned it properly, we can just right click on them. If we right click on them, we'll see that the loads, we applied a uniform dead load of 16 pound per feet square and live load of 40 pound per feet square. So that really makes it clear to us. Now let's apply the roof load as well. Now let's see what the standard or what the ASCE 7 specifies for the minimum roof load. In the roof load category, we have some cases. For example, ordinary flat, pitched or curved roof, we have 20 PSF, and for roofs, for roof gardens, we have 100. Because it involves soil and some other pottery and maybe some cement pots and everything, so that would add to it. So and if it's considered for assembly purposes, same as occupancy served, whatever is here has to be applied for other occupancies. And then we have some other cases. So let's consider the typical one for all other construction, say 20. So let's assume a typical value of 20. So we have gone there, and this is considered to be the live load. So let's select the slabs first, and then let's click on this assign shell loads, uniform shell load. Let's give a value of 20, and again replacing doesn't matter because this is the first live load that we are applying here. So click OK, apply, and OK. And when we right click on this, we see that we have 16 and 20 right here. Now we also need to add the load of the masonry or the walls. Now let's assume we have 9-inch walls here on the exterior, and the interior walls as 6 inches. And for that we need to go into assign frame load here, and we have distributed load. Now before that we need to select them. Now let's see, when we try to select this one, when we try to select this, we have only this being selected. So let's select on all stories. When we select something, we have all these selected. So let's use this option and start selecting the exterior beams. I click on select, and I select all the exterior beams. Select. Now I've selected all the exterior beams. Now I need to apply my uniformly distributed load on these. So I'm going to click assign and frame load, distributed load, and I am applying a uniform load, which comes under the dead load category, and this value is considering the reduction from the beam depth, it will be 10.5 feet times the unit weight of concrete is 145, or the masonry is 145, times the width is 9 inches, which is 0.75. So when we hit this, it calculates the uniformly distributed load here, and click apply. OK, and we can see that the load has been applied. We can go through the depth to make sure that it has been applied evenly. So it has been applied. Now we need to apply the interior loads. So let's click on all the interior beams which correspond to location of the partition walls. We can also have a wall here, and we can again use the same options. So frame, distributed load, and again here we are going to use a 6-inch thickness wall. So again I'm going to repeat 10.5 times 0.145 times 6-inch corresponds to 0.5 feet. 0.5, that is 0.76. Click apply. OK, so I have applied my my uniformly distributed loads on all the interior beams as well, for the interior partition walls as well. Now since this has been these all have been done, let's move into the analysis. Before we go into analysis, we also need to define the load combinations. So to define the load combinations, move into define. We have load combinations, and we can enter add new combo. So we know that provided that we have dead load and live load, we have two possible load combinations. One is from the dead load alone, which is 1.4 dead load, and the other one is from the combination from the dead load and live load, which is 1.2 dead load times 1.6 live load. This is provided in the ASCE manual. So let's create the first one. Let's call it 1.4 dead load. Let's provide a scale factor of 1.4. Okay. And then we have one more load combination, which we can name it as 1.2 dead load plus 1.6 live load. This is just a name that we provide for identification. We have 1.2 dead load, and then we have a live load of 1.4. Okay, so we have created the two load combinations. For proper analysis of the shell loads, we often mesh the shells. So for that we go into mesh, shell, and floor auto mesh options, and then we use the auto cookie, and we specify a mesh size. For example, I'm going to specify a mesh size of 24 inches. Apply. We have not selected it, so go back. Currently it is on default, so select all stories and select all the shell elements and click apply. Okay, if we want to view the mesh, we have to go into display options, and then we can see shell analysis mesh. Apply. Okay, and we can see the way in which the software made the mesh. To change the support condition, let's move into one story, and we can go down until we reach the support, and we can select all of these and just change the support type by assign, joint, restrain, and we can provide any other support type. Now suppose I want to keep it as fixed, just apply, and fixed boundary condition is enforced. So let's do the analysis next. So click on analyze, run analysis. Let's save it as 3D02. The software performs the analysis, and we get a quick view of the deformation. And to see some of the things such as support reactions, just click on the load combination that we require, and we need the support reaction in C, XYZ. Apply OK. We see the support reaction in all the directions. Now if we want to see some of the other internal forces, let's click on axial force, apply. We can see the axial forces on each story. If we want to take a look at the values, click on OK. We see the values right over here on each floor. And then if we want to take a look at the moment, apply, we see the bending moment diagram. And if we want to see in 2.2, the moment on the columns are seen. If you want to take a look at the shear, you can see the shear force diagram.